All right, welcome back, everybody. Today we have a really cool guest on the podcast. This is Mr. Alexis Zeigler, who lives in Virginia in an off-grid small farm community called Living Energy Farm. And uh, they have a bunch of really, really interesting innovations, especially in the energy department, which we're going to get into today for efficient off-grid living. I don't think we need to do too much of an intro, but I think to start out, Alexis, if you could give us just kind of a thumbnail sketch about your project, Living Energy Farms, how many people are involved, what's it like, what are the key details, how long have you been doing this project, what are some of the overarching mission agendas and things like that, and just give the listeners who aren't familiar with your project kind of an overall picture.
Okay, very well. Yeah, we're a small community, 8 to 10 or 12. We tend to have a few more people in the summer. We have 125 acres of land in central Virginia, Louisa County. Louisa is interesting because it has a number of other intentional communities in the area. Twin Oaks has a lot to do with the reason we're here. Me and my partner, Debbie, both live there. And there's a number of other communities, Acorn Community, which runs Southern Exposure Seed Exchange, as well as a few others, Cambia, Mimosa, a few others. So that's a big part of the reason we ended up in this area. We've been here about 13 years. The idea from the beginning was to build a community that, at least on a daily basis, operates without fossil fuel, but does so inexpensively. So we look for things that are inexpensive and durable. The idea, it's really unfortunate, and I don't want to spend a lot of time talking about mainstream environmentalism, but trying to help middle class people feel better about themselves is very different than trying to find a model that 8 billion people can live with. Mm-hmm. And naturally, what indigenous people in the Sahara desert's very different than what people in the Arctic Circle are going to do. But that said, 90% of humanity doesn't have a car, for instance. So, are electric cars an environmental technology? Well, for me, they're not. So what we're looking for at Living Energy Farm, naturally, we are American citizens in a wealthy nation. We have access to a lot of resources, but we're trying to the greatest extent possible, try to figure out how a community can live, be reasonably food and economically self-sufficient, and to create a model that, to the greatest extent possible, can go around the world. And that really has defined us as being very different from most of the environmental organizations we interface with. And it's not accidental that the entire concept of conservation and living more simply gets kicked to the curb. I mean, that's a very systematic political process. And so we're very aware of that. Maybe we'd be rich and famous if we were, doing what, all the other mainstream environmental leaders do, but that's fine. I'm very happy at what we've been able to do and what we've been able to accomplish. At the mechanical, physical, energetic level, the communities come together pretty well. I mean, we'll talk about our various successes and failures, but we do grow most of our own food. We've developed what we call a DC microgrid, which we'll talk about, direct drive DC microgrid, that's worked out really well in terms of solar energy, and our solar thermal systems have worked out well. There's a number of other technologies we're working on. And of course, I'd love to see a lot of other people doing this. So the daily discussion here is, how do we get more people to be willing to live this way? Because we're pretty comfortable. I mean, here I'm, powering this internet link with a fairly low cost, simple version of a solar kit compared to what most people who try to go off grid are accustomed to. Works great. I'm sitting here, our house is pretty warm from heat gathered yesterday. We got partly cloudy today. Now, it has been a cold, cloudy winter, and, we live with more temperature variation, but still we can go through a winter without burning any firewood for heat, and it's okay. It's a little cool, but it's pretty different than what most people are used to. But it's, the entire conservationist model, like if we bring our resource use down and then meet those much more meager demands with renewable energy, there's a meeting point there where that can happen. Mm-hmm. And that can be, could be available to all of humanity, really. So that's what we want, to try to push that forward as best we can.
Well, so I want to ask you about your start out thinking process. So you were working with these other communities that are kind of in your region or in your county in Central Virginia, and then you guys split off to form this project, and you're motivated by this idea of matching your energy to, you're not just trying to reproduce the typical middle class US lifestyle, but supply it by other means. So when you start out thinking about that process, do you kind of do some kind of an audit or something and say, okay, these are the major sectors of the typical life that consume the most energy and resources. So, do you kind of start to knock those out first? Or do you say, okay, let's just start with a bare piece of land and then just start to build up from that direction? Or like, what is your thinking process of moving from, say, a typical middle class exist, because we're embedded in US culture and infrastructure and all this stuff, and it's not immediately apparent how to take a step towards something like what you're doing. So for something just maybe at the very beginning of that, what do you see as the first steps?
Well, when I talk to people, when I give tours at Living Energy Farm, I mean, in terms of the design process, yeah, there was a lot of thought that went into how to do it. And certainly things have changed, but the basic aspects of how to organize the community were there from the beginning. And what I tell people, it's really two questions that sound very similar, but in fact are kind of opposites. The mainstream environmental question is, how do I get what I want with renewable energy? And it sounds innocent, except it's not. And our question is, how do I adjust my lifestyle to live within a reasonably modest renewable energy budget? Sounds very similar, but it's a completely opposite question. So when we started out here, we actually called ourselves Amish without the patriarchy. That was our sort of tongue-in-cheek way of referring to ourselves. And we had boxes of wax. I had built a lot of off-grid solar kits for my friends, and they all fail because they're all battery-based and they're expensive and they don't work. So we thought, I don't know, we're going to be carrying buckets. So, we were going to put in some electrical stuff, but we didn't know how well it was going to work. But the real magic bullet that makes renewable energy work, this is what I tell people on our little tours, is cooperation. If you look at solar hot water, for instance, now if you're in the tropics, it's a different deal. But if you're in North Carolina or Virginia, it gets kind of cold in the winter, and it would really be unfortunate to not have any hot water. So people want hot water. Well, if you, let's say you've got a partner and you're living in a house, you go to a solar installer and say, "Oh, build me a solar hot water system." They're going to say, okay, $10,000, $15,000 or something crazy. You're going to say, whoa, that's nuts. So for us, we have more than I'd say $6,000 or $7,000 worth of solar hot water equipment on the property, but it's a lifetime solar hot water supply for 10 or 20 people. So the magic bullet that makes renewable energy work, particularly in a temperate climate, but also in the tropics, is cooperation. You need to ask yourself, how can I share thermal systems, meaning the building envelope, with 10 to 20 people? How can I share the hot water system with 10 to 20 people? And the thermal loads are really much more significant than the electrical loads. Basically, what's happened is electrical contractors with a lot of federal subsidies are making tons of money off of PV panels, installing them and all of that. It's really not the low-hanging fruit in terms of environmental protection or reducing your environmental footprint. And I knew this before we built Living Energy Farm. I had built a cooperative house in Charlottesville. The per capita energy use there was below 10%, if 100% is the American average, and there's no solar electricity on it at all. But it was really well insulated, and it was a cooperative house. So for the insulation, we do straw bale. And if you got one big house, it's got a lot less surface area than a bunch of little houses. People like tiny houses, but the thermal loss through the walls on a tiny house is pretty terrible. And of course, Americans now live often alone or in very large houses, mainstream, certainly wealthy people. And you can't make that environmental. There's nothing you can do to make that more environmental. So the real key ingredient here is cooperation and then obeying the laws of physics instead of like pretending we're going to use politics to change the laws of physics. And that's how you bring your energy use down 90 to 99%, somewhere in there. And then when you've got that much smaller energy load and you're willing to adjust your lifestyle a little bit, then renewable energy becomes a very powerful thing. So if you try to flip that upside down and you just throw renewable energy at whatever consumer demands you may have, it's a disaster. And that is precisely what's happening. So we're trying to, and there's a big movement out there, degrowth, and well, you guys probably know more about it than I do. So, we're trying to actually find the nuts and bolts of like, okay, what comes after industrialism? If we're going to try to glide industrialism down instead of going off a cliff, we all know industrial output is going to decline. It would really be better if it came down slowly rather than off the cliff. I don't know what's going to happen, but whether we're trying to glide it down or figure out what's going to happen 100 or 200 years from now, it's really the same question. How do we grow food, pump water? How do we sustain ourselves? Because we're not going to eat acorns and squirrels. I mean, not with 8 billion people. We have to have a more sophisticated answer than that. So that's the question we're trying to answer.
I have a quick question. So I don't think anyone has said this on the pod before, and I've never really thought about it this way, but it's neither what you seem to have just said is it's neither sustainable to do every single person, every individual or every individual household, let's say nuclear family has their own off-grid system, nor is it sustainable really, or makes sense with the laws of physics to have these like super hyper-connected grids that go to everybody that then have points of failure that can have cascading points of failure. I'm wondering whether or not, Alexis, you, and then I know Josh is like probably a nerd on these kinds of things, to talk about why this 10 to 20, like via the physics, why does it work? Why is it more resilient?
It's radically more resilient. Well, let's say 10 to 100. I mean, if you had a apartment building with 100 people in it, well, just nuts and bolts. Here in Louisa County, Virginia, we have power outages. We have a big thunderstorm. Occasionally a hurricane comes up the coast. 2 winters ago, we had a big surprise snowstorm. It was predicted to be 3 inches. It turned out to be 16 inches. If you've ever seen a clothesline where the snow will stack up about an inch on top of the clothesline,
Yeah.
the clothesline's turned into softballs. The snow is so sticky, it just blah. So you know what that did to the trees. So our local power company is Rappahannock, and every single one of their customers was without power. In 13 years, the lights have never gone out here. So I have a metal shop. We have our DC microgrid runs on 90% of our energy never goes through a battery, goes straight from a set of PV panels straight to the end use, which includes a whole lot of motors that do work, everything from food processing to, I have a machine shop. Just this morning, I was out there working on a machine, and it's cloudy, it's overcast, the heating blowers are running, and I'm still drilling steel. That's what I'm doing. And you can overload the system. DC motors can tolerate 500% voltage variation. AC motors can tolerate 10%, roughly. So these systems, by tolerating a system that, floats a bit. So if it's like raining and snowing, I'm not cutting firewood with my electric saw, but I don't want to cut firewood when it's raining and snowing. By tolerating a system that has some fluctuation built into it, it would be a bit uncomfortable for us if all of civilization went away, but we'd basically be okay. We can feed ourselves. We can take care of our own needs. We don't have the farm quite nailed down yet. We're working on that. But this system doesn't fail. I mean, the advantages of the system we have, including the thermal systems that make the DC microgrid work, it costs about 80% less to build, give or take, than a conventional battery-based off-grid kit. It costs almost zero to maintain it. I mean, not quite nothing, and you got to count depreciation, but it's like it runs. We use nickel iron batteries for the lights, and those last for decades. And then it never fails. The fact that we allow it to fluctuate, there's certain days when I can't do everything. I can't cut firewood, but the whole system never fails. It just keeps going for a lifetime. So it's a great system. And 90% of humanity would die to have this system if they understood it. And that richest 10% are like, we don't want it. But it's that rich 10% that drives consumerism. So it's, and I don't want to paint too rosy of a picture of it in the sense of, there are like, we let the building cool off some. I mean, it's really good solar, and this winter's kind of kicked our butt. Okay, so the building cools off some. But, in Ukraine, with this terrible war they have, people are dying because the Russians bombed their power system and the house cools off. Same in the US. If the grid goes down, people die. Well, we're in no risk of death from lack of heat because our building holds the heat and it's just solar. And the idea that solar is more expensive than conventional systems is just wrong. There's a thing that therapists say that anybody who's not ready for therapy will tell you therapy is too expensive. And, maybe therapy is too expensive, but when you're ready for something, then you do it. And, a straw bale house is not free. I mean, I would say it's roughly the same cost as a regular house. And at this point, we're talking about off-grid condos, because I think the situation we have here with shared bathrooms and shared kitchen is a little too much sharing, maybe for most Americans. So we're trying to think of maybe small apartments with a thermal shell around them.
Oh, that's smart.
Trying to, yeah. If somebody wants to help us fund that, because nothing's free. But a well-built solar thermal house is, either the same price or maybe 20-30% more for the whole house, but the per capita cost is whatever, a whole lot cheaper. I don't want to make up numbers off the cuff here, but it's way cheaper. The off-grid condo, I mean, I'm sure we could do it for under $50,000. This house was about $15,000 per capita. The one I mentioned previously that we did in Charlottesville was $14,500 per capita, including the price of the land, to build a house that uses less than 10% as much energy. They were building straw bale houses back in 500 years ago in Germany and 120 years ago in the US.
Yeah.
But that conservationist economy, where we don't consume so much stuff, we take care of a lot of our own needs, it's community-based, that economy, if you imagine everybody started doing that, would have a much harder time building aircraft carriers and tanks and conquering the world. We live in a very conquest-oriented imperial society, and that trickles all the way down to homesteaders who just don't know that they can build thick walls for the same price as thin walls. I mean, I built thick-walled houses, 18-inch thick walls out of leaves, straw, bamboo, crumpled up newspaper, whatever. Make a thick wall, put some windows on the south side, and you knock your energy use down 70 or 80%. Never mind the DC microgrid. I mean, I like the DC microgrid, it's cool. But that's culture. It's like, okay, women wear their hair long. You've actually got long hair, but most men keep their hair short. That's culture, okay? Long hair, short hair, mostly harmless, I think. But we have inherited a throughput culture. The more we consume, the more powerful we get. Think of if the United States suddenly stopped consuming. All of this military and economic power we have would start to shrink. Now, in a more peaceful world, that would be a good thing. But we live in a world where there's been a lot of warfare, and we've built these cultures that are based on, consuming, moving resources through. But as individuals, we need to understand that we're not committed to those choices. You don't have to build a thin wall house. You don't have to live in a big house by yourself. You don't have to. You've got choices. And those choices can be tremendously empowering.
So I think throughout the conversation, we'll kind of return to this theme of just shifting philosophy and thinking differently than is common kind of in mainstream U.S. culture. You've indicated the importance of insulation and other things that are in the walls that you don't see, that maybe don't have the sexiness of a fancy Tesla with the battery or whatever out in the front driveway or something like that. But what I definitely want to drill into the DC microgrids and how you run all the different implements that you run on that kind of thing, and to go a little bit nerdy in terms of the technical details of how the pieces fit together and how you've sort of figured it out. But let's step out to the big picture and work our way into that. So in the US, our electrical grid system is AC power, correct? Right.
Yep.
Okay. And you're building a DC-based microgrid. So just give us a rundown of the sort of advantages and disadvantages of AC versus DC, and why is it that our grid is AC power, whereas a lot of appliances or a lot of the things that you're promoting are DC? Like, why don't we have a DC grid? Why don't we just run everything on DC if that's more efficient? Kind of, unpack that a little bit.
Sure. I will gladly do that. I will preface it by saying that DC itself is not a magic bullet, that if you try to do DC systems with the same consumerist madness, it's just going to be DC consumerism. But that said, DC and AC are different. So AC with a generator that's spinning, and they had boilers hundreds of years ago and created generators. I don't know when the first generator was created, but it goes back a while. A generator can create AC or DC. But AC, before the era of modern electronics, is really easy to step the voltage up. A transformer is simply two coils of copper wire. And depending on the size of the coils and how they're positioned, you can step voltage up or down. And so the distribution that we have, the lowest voltage lines are 7,000 volts. Those big steel towers, those are 500,000 to 865,000, I think is the highest. So, thousands and thousands of volts of AC wire. It's very easy to step the voltage up, and then AC powered high voltage will go down a wire a long, long ways with very little loss. So, and solar panels, PV panels, photovoltaic panels, of course, were only created after World War II and only recently entering the mass market. But if you think about, so it's the mid-late 1800s when they started thinking about, hey, let's have electric lights in New York City. They didn't have solar panels. They had boilers and generators. So they could create a generator and create the transformer and send the power down the wire, and that worked. It's harder with DC to jack the voltage and send it down a wire. It's just doesn't work as well that way. But the advantages of DC are, first of all, solar panels put out DC. AC, is a sine wave. DC is a flat line. That's how it's represented. Solar panels and batteries always put out solar electric panels, not solar thermal panels, always put out DC. But it turns out that, like I said earlier, DC motor, they're called permanent magnet motors or brush motors. They will tolerate crazy voltage swings. They actually use them in industry historically for conveyor lines or anything that needs to speed up and slow down. They also use them in really huge machines, like the big monster dump trucks or freight trains. Those things actually have big old DC motors in the wheels, because the drivetrain would be pretty crazy if you had to have a 8,000 horsepower diesel engine driving a transmission. That would get nuts. So they use electricity, and the speed varies. So what happens with us, the two magic voltages for high voltage DC are either 180 or 90. Most solar panels are in the 30, 40 volt range. You can do 6 in series to get 180. Now that's what we did, but it's actually better to do 3 to get 90, 3 more to get 90, and put those in parallel. So with a 90 or 180 volt motor, you can just go online to any industrial supplier, go on, eBay or wherever, and get a used ones if you want, and you just plug it straight into the wire and it runs. So a lot of our equipment, all the metalworking equipment. So I have a machine shop. I have a lathe and a mill and a bandsaw and drill press and compressors and grinders and all that stuff. Just swap out the motors. So like with a grinder, for instance, a modern grinder, the grinder stones are right on the shaft of the motor. We don't use those. We get an older grinder with a belt, so we can swap the DC motor, and then the belt runs to the grinder, makes it easier to swap. So those are dedicated DC motors. Food processing equipment goes different directions. So we don't buy any flour. We grind all our own flour. We've got a fairly nice grinder, and that also is belt driven off of a DC motor. So today is like pretty heavy overcast, but the motors still run. They just speed up and slow down. And even if they go to a full stop, it doesn't break anything. Okay, well, I got it overloaded. Let's turn something off. And we run fewer things on cloudier days. So those are the brush motors, as we call them. The funny thing is that, so any motor that you can pick up and walk around your house with, any small appliance, and that includes old-fashioned power tools with a cord, any blender, vacuum cleaner, shop vac, food processor, anything like that. Like if you notice the old-fashioned drills with the cord, when you're looking at the back of the drill, you see the little blue sparks flying around in there. That's a brush motor. It's called a universal motor. And about 90% of those will run straight off the solar panels. So that's the reason we like to do 3 and 3 to get the 90, because it's actually 90 to 120 in that range. So you can just go to the hardware store, get a blender, or take a blender you've already got. If you do 3 and 3 and you got 90 volts, you plug it in there, turn it on, it runs straight DC. The only trick is that DC, as a switch, opens and closes, and AC switch doesn't arc much. Because of the pulse in the AC, as the arc starts to form, it breaks the arc and the switch opens. DC, as the switch opens, it starts an arc and it sustains an arc. If you've ever seen an arc welder, an arc generates a whole lot of heat. So we either use heavier switches, which are, $20-$30, not crazy expensive, or we use these little things. They're just capacitors or snubbers, they're called. You put it across the switch, kind of absorbs the arc. So you do have to modify the switching, either fiddle with your AC switch or put in a different switch if you're going to run the universal motors. Now, your big appliances, like if you got a washing machine, I don't know, dishwasher, who has those things, they're crazy, but that has what's called an induction motor. You can't run those DC. That's just doesn't work. And then there are other kinds of DC motors. There's brushless motors. Those are more modern, more efficient, a little more expensive usually, but they're more available now. So for some applications, like our well is 300 feet down, there's a submersible pump down there that has a brushless motor, because you don't have to pull that thing out to fix it. The brush motors, every 4 or 5 years, you got to fiddle with the brushes. The pump's been down there, let's sit down there for 20 years. That's better for that to be brushless.
Right.
And so one of the problems is that DC appliances are not easily available necessarily. So some of these conversions are easy. The blender's fairly easy. The pumps are the easiest because of the number of farmers globally who want to pump water with solar energy. They're Chinese, European, American. There's a bunch of companies making hundreds of different kinds of pumps. You can spend $20, $2,000, $10,000, depending on whether you want a little pump, big pump, whatever, any kind of pump you want. Whereas a washing machine to wash your clothes, There, to my knowledge, there are some cheap Chinese low voltage washing machines that we haven't messed with those because I'm allergic to cheap appliances, but there's not, to our knowledge, there's not a good quality DC washing machine on the market, period. So that's a problem. We're trying to fix it. That's one of our projects. We're working on a better washing machine here. And the one we have works pretty well, or we've got a prototype that's working. So, but the big advantage, so the reason so I told you, I've helped a lot of my friends build these conventional off-grid systems. They put in a big old monster battery bank, usually lead acid. They say, oh, that thing will last 12 years. Well, it lasts 3 years on the first set.
Yeah. Yeah.
And then the second set, you get 4 or 5, and that's it. You're done, 5 or 6.
Yeah.
What I tell people is that lead acid batteries work as long as you don't use them. If you use them, you degrade them and then they break. And then you realize when you're spending $1,000 or $2,000 a year replacing batteries, crazy. The other problem is that you remember that 10% voltage variation. So a battery bank running an inverter that takes the DC and makes it into AC, that system cannot weaken. So if you've got, just to make up a number, 5 horsepower, 5 kilowatts worth of appliances in your kitchen and stuff you really need to run, you need maybe 10 kilowatts of supply because that 120 volts AC cannot fall. So what happens with the inverter, as soon as the battery is weakened a little bit, boom, it turns off. And that's what happens. And then you're like, oh my God, I've got to go start the generator, this stuff. What happens for us is the system, we have, first of all, instead of having one big system, we actually have 8 systems. So like the refrigerator has 5 inches of foam around it instead of 1. It has a German-made compressor in it that will tolerate the voltage fluctuation, and it's a DC compressor. So in bright sunny weather, it chills down. In cloudy weather, it chills down a little more slowly, but and then it gets cold during the day, and then it stays cold at night. Brilliant, right? Just a little bit of foam and all the nuclear coal and frack gas and all that goes away. You just insulation. But the trick is that motor can tolerate, that particular motor can tolerate 10 to 45 volts. Voltage swings all around, motor just speeds up, slows down, and it's happy. At some point, it turns off. Whereas with an AC system, if there's any softening, it just turns right off. So right now on our high voltage system, that's our biggest system out of the 8. Some of them are tiny, like that fridge circuit is just one panel going to the fridge. That's it. That's the whole circuit. But that's part of the resilience, because if there's ever any trouble anywhere else, doesn't affect the fridge. And we actually took a lightning strike on the fridge at one point. It blew out a little piece of electronics. Didn't affect anything else. So the whole system is tremendously resilient. And, you know, it can fluctuate. So we've got, on our high voltage system, we've got 1,400 watts, 1.4 kilowatts. I have 16 kilowatts worth of motors tied to that system at this point. And we can run on a sunny day 4 or 5 kilowatts with 1.4 kilowatt supply. Just the motors speed up and slow down. So this morning out in the machine shop, I've got a 3/4 horsepower motor blower running in the house, pulling heat off the roof and blowing it under the floor. Thermal storage is always cheaper than electrical storage. The solar hot water pumps are running, doing their thing. They do that for 30 years without me thinking about it. So I get to take a hot shower tonight without even thinking about it. The fridge is running. I don't have to think about that. There's another high voltage blower running in the kitchen, pulling heat under the floor. And I was out in the shop this morning running a bandsaw and a mill. That's a big drill thing, all at the same time on a partly cloudy day. And again, it's not miraculous. There are annoyances and frustrations. And this winter has certainly had its annoyances because it's been really cloudy and really cold, but whatever. You know, we get used to those inconveniences that we associate with our class status. Like if middle class people live by themselves and drive to work on a crazy suicidal road, we think that's normal. Whereas, you know, historically, to ostracize somebody was considered a punishment worse than death. And now we ostracize ourselves on purpose. So if you tell me Americans aren't willing to endure deprivation, no, we're willing to endure the deprivation we're told we're supposed to endure. You know, if rich people came on and said, you know, here's all these young, sexy people and look at them enjoying a conservationist lifestyle, and they put that on television commercials during the Super Bowl, then we'd all do that now, wouldn't we? So what we have here is a system that can, you know, we can pump water, we can grow food, we can make machines, we can bake bread with solar energy, we can do all this stuff with a, you know, a modest energy set. It's still probably too big a little bit to really sustain 8 billion people, but we're trying to bring it down, you know, do it the best we can. So I think it's a great system.
So I want to highlight a couple things to recap from what you were talking about. When you're talking about the difference between AC and DC, it sounds like one of the main advantages of AC is that you can transmit power over long distances. So that's great for a giant grid that goes over long distances. DC power can't be transmitted over quite as long of distances. So your whole system needs to be pretty much co-located. You're not sending power down the road to your neighbors or something from your grid, from your DC system. And then the motors that are made to run on these things, for whatever reason, physics, the DC motors can tolerate these voltage fluctuations. AC can't. You start to burn out the motor if you have like a motor if you have too low a voltage or something like that. So your system will just speed up and slow down to accommodate whatever power is coming into it, right? And it turns out that a lot of things that we use in our daily lives actually can run on these DC things. But we have AC coming into the house. You plug something into the AC, and then presumably that gets converted to DC to run the little DC motor thing that you're operating, right? Or in a solar PV system, you have a panel, a battery bank, an inverter going to your house to AC, going into something, getting turned back into DC to do the work. So like with all of these conversion steps, you're losing a lot of power, right? I mean, so the idea is like, stop converting it back and forth and back and forth and back and forth and just use it directly. Is that the idea behind your setup?
Yeah, I mean, what you said is a decent summary. I mean, there are a couple of things. I mean, you can actually send DC long distance. I've had some scientists get jacked up with me about that. It's just a lot harder and a lot more expensive. And in a house, some things get converted, go from DC to AC to DC back and forth. Some things don't. Like an AC induction motor doesn't actually convert to DC. It just runs on the straight AC. Whereas anything electronic, there is no such thing as AC electronics. Everything electronic is DC. So yeah, and it's not even the loss of efficiency because we've gotten pretty good at making those transitions. It's the complexity, the fact that the AC systems fall apart so easily. They're just more complicated, and why bother? And the fact that solar panels put out DC. If solar panels put out AC, I suppose we'd be doing something different. But if you can do the solar panels, and it's just a much simpler, more resilient system. And yeah, it works a whole lot better if you're not trying to send it far away.
So with these systems that you have, then you've built all this stuff at your place. Is all this like cobbled together, custom kind of thing? Do you offer tutorials on how to do this? Do you have actual equipment that you're producing that's kind of like plug and play ready to go? Or like how, if somebody's like, oh, I like this idea of a DC power system in my house or my shop, what do I need to get to make that happen?
So I think the best resource, of course, there are two websites. There's livingenergyfarm.org. And as far as stuff that we can provide, there's livingenergylights.com. Now that is a private corporation. It's kind of a quasi nonprofit. It gets a lot of, and it's not big, it's just us. We get nonprofit money, and that's how we're doing the work in Puerto Rico and whatnot. We can talk about that. And we have some equipment available, not a ton of it, because that's a big problem with the spread of DC power systems is that there's not as much profit in it. You know, corporations these days are not interested in modest profits. They want big profits. They want big markets. So that's something that cripples energy, agriculture, everything. Everywhere where people need small tools, they don't have them because the big corporations won't make them. So we're trying to do what we can to address that. There's another good resource. So our websites, both of those websites, you can just cruise around and click, and there's some documents there. Well, some of it's a little dated, but most of it's pretty accurate still. We did try to consolidate. So there's a book, self-published book, Empowering Communities. It's linked off of the Living Energy Farm website. It should be off the livingenergylights.com website as well. So livingenergyfarm is .org and livingenergylights is .com. I have a personal website, which is just conev.org, CONEV.org, and it's linked off of there too. So Empowering Communities, it's a free download. We do print copies that we, sell for a few bucks here at the farm. If you look through that, that's as much resources as we have. There are people all over the world doing this, and it is growing rapidly because DC systems work. You can't bend the laws of physics however much you may want to. But there's a fundamental problem in that rich people don't want it and poor people can't afford it in terms of the growth. And I don't know that, capitalism, to me, small scale capitalism is fine. This big corporatist state we have is not capitalist, and are the communist states any better? I don't want to talk about all that. But there is just a basic problem with the market mechanisms in that getting stuff that poor people need to providing that stuff is hard. We have pulled together as much money as we can to buy. So the nickel iron batteries, they're another great technology. That's an older technology. They're also called Edison batteries. So, we brought in DC fans and we buy DC motors. We get those here. We're bringing in equipment from all over the place. We've got projects going in Puerto Rico in particular, in Jamaica as well. So the capital flows. Obviously, if we had millions of dollars, we could make that move more quickly. And what's happened in sub-Saharan Africa is the biggest part of the world that doesn't have solar power. But the people who go in there and market stuff, it's a lot of cheap Chinese junk often. And it's interesting. I don't want to spend too much time kvetching about other nonprofits, but a lot of what pretends to be helping people is raising tons of money to export racist ideas that if those poor brown people just live like we do, everything would be fine. So Americans, Westerners in general, have this individualistic mindset. So they always design their energy systems based on that mindset. Whereas a DC microgrid works when you're thinking about a village of, like I said, 10 to 100 people, whatever. They just can't get their head around that. They won't do it. We have talked to a lot of nonprofits and worked with some, and big complicated story, but they really just think that those poor farmers in Africa should live like we do. So they want to give them a battery and then a bigger battery and then tie the batteries together so they can all have something resembling a modern middle-class lifestyle, except it's never going to happen because they can't afford it. And they know that. We've talked to them. It's like, our system's better, and they know it's better, but the whole funding chain is all about getting them to live like we do. It really comes down to the fact that rich, mostly white liberals, that it's guilt relief, that if we can pretend that we can provide the whole world with a middle-class American lifestyle, then that justifies our living that way. That's really what it comes down to. It's got nothing to do with what actually works.
Right. I'm wondering whether or not there is a pitch to be made. I think a lot about these like appropriate technology systems. Things like when I lived in Uruguay, we had like a passive solar water heater, and people like maybe like a rocket mass heater, and then what you are talking about, this DC microgrid. Like, why is there not a Silicon Valley funded, maybe not Silicon Valley because they're not going to make those kind of venture capital returns, but like these whiz bang techno optimist types, why isn't somebody dedicated to making a high quality DC microgrid that could be sold to communities of 10 to 100, that's like consumer grade, off the shelf, type system? Like why? I don't understand why we have all these people spinning their wheels on like brand new technologies that are often silly or often break, like things like vertical farms that are just such a complete energy waste, but nobody's like dedicated to doing this for the global north.
I don't know. No, I don't. You've asked a very good question, and I don't have an answer for it.
Yeah.
I mean, we don't spend a lot of time. We do what we can to promote our ideas. I mean, if you've got some ideas of how to promote it, if anybody who listens to this is like, I mean, we're going to try to pull in more capital. We've got a few people who support us, and it's thousands and tens of thousands of dollars. It's not hundreds of thousands. It's not millions, certainly. But if you know of people out there who would be willing to do that, I think both in the industrial world and in the non-industrial world, these technologies could be packaged and could be marketed at a profit. I'm not saying that profit is virtue. I don't believe that, but could be an economically self-sustaining project.
Right.
So I don't know. I don't have the
answer. I don't know.
That
is one of the ongoing questions of this podcast is why people like you and there are a lot of people who are sort of independently working out the necessities of what a post-industrial but comfortable, but maybe not super energy intensive or resource intensive, but comfortable post-industrial life would take. And a lot of people are sort of independently experimenting with these things. I think we do have some connections or people who listen to this podcast who are interested or connected to investors who are also sort of doomer in terms of the industrial society and future, but usually they're not connected to those on the ground types who are doing the experimentation and sort of have built out these systems. And so maybe one day somebody who's listening to this will make those connections and make that happen. Sorry, I'll toss it back over to Josh.
I hope so.
Yeah, I want to get you to comment on one thing, and then let's talk about Puerto Rico and Jamaica. But one of the things that stands out about what you have presented is, and in light of this conversation about how sort of mainstream environmentalism is barking up the wrong tree in a lot of ways. I mean, you guys have developed this stuff because you need to use it where you live. Like you live by the technology that you know. So but I feel like a lot of the sort of helping professions of going abroad, it's like here's this thing that was designed for poor people that no one actually
Right.
lives by and has to use. Whereas, I mean, I think people on this podcast and maybe in general, there's a growing sense of the, and this is, this is counter the tech solutions culture, but the idea that of convergence between we're currently the rich country, but we're not going to be forever and not much longer, and the kind of technologies you're presenting it's as beneficial for people like us to migrate towards those kind of things to reduce pressure on the biosphere by our over consuming lives and also
Mhm.
extend that opportunity to people in developing countries. And so maybe you can comment a little bit on the importance of living by the technologies that you promote and how that figures into your approach. And then maybe try to segue into it. Sounds like you've got some really interesting on the ground work going on in Jamaica and Puerto Rico. So give us an idea about how those projects are unfolding.
Sure. I mean, I think, it's interesting because there's nothing that we do at Living Energy Farm that defies the laws of physics, obviously. But it's not something you would sit down doing mathematical equations. You would realize how well it works. You wouldn't, add up the watts and come up with the idea that you can run 3,000 watts worth of motors off of 1,000 watts worth of supply. You just wouldn't. And the scientists don't get it. And it's exactly, I was nodding my head like, yeah, there's a bunch of scientists who live, they're very wealthy. I mean, and these bigger nonprofits that do this work overseas, they've got like hired electrical engineers. All of these guys live in nice houses and they drive the car to work. And yeah, they're not living what they're talking about. And you could call it racist, I don't know, whatever. So yeah, I think living with it day to day, we really see like our biogas system. I don't want to spend too much on that, but that's something that really has to have 8 or 10 people. It's just in a temperate climate. In a tropical climate, biogas is a lot easier. But in a temperate climate, you've got to keep an outdoor tank of some size above 85 degrees and feed it. You can't do that by yourself. You really need a small community supporting that. And ideally, I think that technology would benefit from 50 or 100 people centered around one biogas digester. I think the post-industrial society, we're going to have one biogas digester on every every village will have one digester basically. And they're kind of doing that in Africa. They're using like big trash bags to carry the biogas around. It's cute. So yeah, it what we've done, and we tried several projects. The ongoing projects now, Puerto Rico is the biggest. We just started a new project in Jamaica. So I would love to get into sub-Saharan Africa, but Puerto Rico's closer. They pay 3 times as much per kilowatt as we do. And the grid, if you've ever been to Puerto Rico, it's steep and the wires are strung all over the place. So they get knocked down pretty easily. And of course, Hurricane Maria, which is about almost 6 years ago now, made a mess, big mess. And they've had a couple of other hurricanes since then that made some mess. What we have found is that the people who are most interested in our technology are less privileged. They're often people of color and they're often not as wealthy. And it's a challenge for us in terms of how do we balance, just making it all work financially. But in Puerto Rico, Jamaica is much poorer than Puerto Rico, but in both locales, they're not starving, but their energy systems are kind of crummy. Both countries have, Puerto Rico is not a country, but both areas have power companies that the local population absolutely loathes. They hate their power company. The power company's corrupt, unreliable, expensive. Everything's wrong with it. And what happened in Puerto Rico, they are a bit wealthier. A bunch of solar companies went down there. They're all over the place. So after Maria, a lot of people would spend $20,000-$30,000 on these big battery-based solar kits. The kit dies and they still have to pay for it. They haven't even finished paying for it and they can't use it because it's dead. So we've, just the solar refrigerators, we've been bringing those down there. Go, here's a solar refrigerator, get it hooked up and it should run 20, 30 years, screw the power company. So people like that. We definitely have a growing following down there. And it's pretty much being run by the Puerto Ricans. There's a couple of organizations. There's a Fundación Boca Rabón, which is in Western Puerto Rico. More in Eastern Puerto Rico, there's El Departamento de la Comida. There's a number of other people and organizations, and they're mostly steering the boat. We're mostly kind of just, okay, tell us what you need. And, we're very involved, but we're not just being the white saviors saying here. They've been here. We've brought several groups here over the last couple of summers to kind of like see what we've got and learn about it. We've been shipping equipment down there as much as we can afford. And they like it. It's like, wow, yeah, okay, a solar system that's way cheaper and way more reliable. I mean, the big problem there is the same problem we have here, and that rich people don't want it, poor people can't afford it. It's not push button energy. It's not thermostatic, so much of the grid power is. Jamaica, we started a project down there a few years ago, and that one didn't go too far. We got a new project there. It's just a farm that's setting up a Jamaican-born woman who came, gender neutral, came to the U.S. and then they went back down there and they're starting this organic farm. And they want to teach people how to farm without chemicals. And they've come here and seen our system. They want that system to grow in Jamaica. So in both areas, there's certainly people who want it. Jamaica is more challenging than Puerto Rico in terms of moving materials in. There's people who want it. There's people who need it. It's really, you were asking earlier about why aren't there some benefactor helping this spread? Certainly, if we could get enough support to go into Puerto Rico and just offer this as a package, it would take off and go on its own. I mean, we're pulling it together. We got one guy, him and his wife, they run a little solar company, but it's small scale. And, we've been in Puerto Rico now for a couple of years. So it's growing at the rate we can grow it. But there's a demand for it. There's interest in it. But it's really hard to do it without the money, and without, and the recognition. Because even, my God, I mean, the biggest problem we have in the modern world is just environmental denial. The second biggest problem is all the money and attention and resources get funneled off into, this crazy middle-class version of solar energy. So, Puerto Rico imports 85% of its food. I think in Jamaica it's maybe 75%, and they're paving over a bunch of the farmland with solar panels in Puerto Rico. For what? To provide power to rich people who can throw it away. And it's the same issue down there. I tell you, the big issue we have in the tropics is air conditioning. You can do direct drive air conditioning, but it's kind of expensive. It's not very easy. So that's a challenge. It's like I said, it's not a magic bullet. There are challenges here. But certainly if with the right kind of marketing and money, it would go. The demand is there, and we're doing what we can. And we try to struggle with trying to get it to the people who really need it, but we're doing what we can. And they're good projects. I think they're definitely worthwhile. And we stuck our fingers into a few things in India, in Africa. Certainly a bunch of people in Europe are interested in what we're doing.
Are there
That's great. Sorry, go ahead, Josh. I have one other comment to make.
Okay, I just wanted to ask if you're talking about trying to find various ways to raise the profile of this work and get funding and more momentum. Are there any universities that have taken an interest in what you're doing and sending people to you to train or to pilot a program for master students to study any of that kind of thing from academia?
Yes and no. There's a fellow named Pete Schwartz in California at Cal Poly who created what he calls ISICs, insulated solar electric cookers. He created that project on his own a few years ago. He builds really small, cheap electric power cookers, and they're great for what they are. We took that idea and we make somewhat larger, but still direct drive cookers. And we've been promoting those in Jamaica, Puerto Rico, other places we go. So that's not Cal Poly, that's Pete. And Pete, he's working hard doing what he can, and he's had some funding, but we have another project to build a very small scale grain harvester. We all eat grain, whatever your diet is, there's a lot of grain involved one way or another. And these days it's all harvested with $500,000 combines, the big monster machines. Mm-hmm. Well, we built a machine that could be made for a few $100, hopefully, that will harvest grain. And so the University of Missouri has gotten involved in that, although again, it's an individual at the University of Missouri, and there's some other organizations involved. So there's not major university involvement, but a few little threads. There's a French organization, Low Tech Lab, that's really gotten involved, and we've gotten a lot of traction, a lot of attention through the stuff that they've done. They came here and they travel around the world documenting small scale renewable technologies. So there's some threads there, but not a major cord.
Well, researchers listening to this and those who are looking to fund things, please get in touch and follow up. I have one comment, which is one thing I found. I'm a social scientist by training, and one thing I found is that a lot of these um, sort of necessity is the mother of invention. You know, a lot of these kinds of systems, if they're at the ready, people will uptake them quickly when a disaster hits. So Puerto Rico is a great example. I did some research with people who build earth ships. And there was one guy, Ralphie, because the earth ship crew is actually kind of small. A lot of people have heard of earth ships, but like the core crew of builders is actually like, you know, like a dozen people or something. Ralphie basically went to Puerto Rico and was like, you know, these earth ships are sort of like disaster proof buildings, and we need to think about them that way. And then, you know, a lot of foundations and NGOs started to become interested as a result of the hurricane. And, you know, when things break down, people seem to be interested. But the question is always, we need some people experimenting with these things before disaster hits, so that when the disaster comes, it's not like this, you know, quick rush to reinvent the wheel, basically. I have one other question in a different direction, unless you had anything else on this particular topic, Josh. Okay. So the DC microgrid system, I'm wondering if you have thoughts on things like a rocket mass heater. Is there a reason you don't do wood stoves at all, or like a rocket stove, or, you know, like coppicing? You know, passive solar in the summer, like a solar oven, passive solar water heater. Is that what you're calling a solar thermal system? Like, I'd be curious to just delineate, you know, a lot of people don't think about where their energy comes from. So delineate systems that use electricity versus systems that sort of, you know, either I'm not using the right term for physics, but taking the solar passively, solar heat passively, or is there a reason not to use wood heating and this kind of stuff? So just thinking about, how do you think about energy holistically, and what's sustainable?
Right. So there was actually a bunch of different technologies you just mentioned there, and they unpack differently. Each one is different. So to look at solar, yeah, we have windows on the south side of the house, passive solar. That's a no-brainer.
Yeah.
If you look at solar cookers, like the solar ovens, yeah, we had those from day one. And from day one, we were doing 5 to 10% of our cooking on solar. Those things, they don't work in cloudy weather. They don't work in cold weather. The cooker's out in the yard. I had a friend of mine who had a project in Latin America promoting those in villages. And he was, he went down there, and it was a good project. It wasn't just he was very personally involved. He talked to me recently. He's an elderly fellow. He said not a single one of those cookers is in use, not one.
Yeah.
Now, when we switched to Pete's design, Pete Calpali, we have a really well-insulated cooker. The problem is getting, for a hot shower, I need 105 degrees. To be in my house in the wintertime, I need 65, maybe 70.
Right.
To cook, you need 250, 300. That's really more challenging with direct solar thermal. It seems like it would be, but so when we switched from the solar oven style cooker, the parabolic cookers, those are actually a little better, I think, than the ovens, to the solar electric cookers, our ratio or fraction of cooking done with solar electricity went from, 7 or 8% to like 80%.
Right.
Pretty quickly.
Right.
It's a very, very big difference. And we're in Virginia. This is not like Arizona.
Right.
So this goes back to what Josh mentioned earlier about all these people. There's big nonprofits that promote solar energy, and all those jokers go home and cook on gas or electricity. They do. I'm promising it.
Yeah.
We live with this stuff, and I'm telling you, and we do use rocket stoves, which is different than a rocket mass heater, because our biogas system got screwed up right at the beginning of the cold weather and is not coming back up to temperature quickly. So it goes. So rocket stoves to cook with, firewood has been our fallback for cooking from day one.
Nice. Okay.
We have a wood stove in the house to back up the solar. We don't use it much. We have a wood water heater to back up the solar thermal for the water heat. And we use that a little bit more than the wood stove in the house. The amount of wood that we burn total is really small. And wood is a mixed bag. It's cheap for people who live in rural areas, but that cheapness often encourages people to overuse it. Like I've seen a lot of people with outdoor boilers. Those things are horrible technology. Or they got a big house and they burn a bunch of wood and they call it sustainable. It's, well, that's not 8 billion people sustainable. That's you burning a bunch of wood. So a lot of wood is not sustainable. And I think within a year we'll be done with the wood for cooking. Just the biogas has been a real long struggle. The rocket mass heaters, I am not on board with those things. So wood combustion can be really well done in a well-engineered wood stove and rocket mass heaters. So first of all, don't worry so much about the heat source. I like straw bale houses. Cheap, easy, fast. Get the insulation right. Get the shared use right. And then your energy source becomes a lot less important. You don't want to fall into this mindset of just because it's small and cheap and funky, it's good. Some
Right.
small, funky things are great, and some of them aren't. The
Right.
problem with rocket mass heaters is a lot of them set themselves on fire. A lot of people underestimate the power of wood to generate heat and degrade the materials in a wood stove. That to break down the long chain hydrocarbons that are put off by wood, you actually need a really hot fire. So modern wood stoves have a secondary combustion chamber. It's either catalytic converter or it's just some stainless steel, whatever. It's done various ways. But I suggest if you're going to back up your solar systems with wood, actually just get a decent stove. They're not that expensive. And the rocket mass heater is either going to burn dirty or burn your house down. Likely is not. I'm not a big fan of those things. If you have something that you're not using very much, like our water heater is not great, but we only fire it 10 or 12 times a year, so it's not super high efficiency, but it is stainless steel. It's made by this Amish company, DNS Machine, out of Pennsylvania, which is great. So yeah, I mean, not everything small and funky is great, but again, you live with it, you figure it out.
Yeah, no, that's helpful. I think just 2 points I'm taking from what you just said. One is it actually user friendly? What you're saying about how often are they using it? How, is it actually practical? Second, I picked up having multiple systems. So you have your primary system that is like the most efficient, but if that's not doing enough, you can have these secondary systems. That's a very smart always for resilience. And then the third point I want to point out is I think for a lot of us modern people, and myself included, who first get into like the world of permaculture and conservation living, the initial idea is like, oh, just because it's permaculture, it's good, like these herb spirals, or people will do. Somebody was making fun of this early on in our podcast, where people will do totally inappropriate building of a, let's say, outdoor pizza oven out of straw bale and mud in like a super wet area and not cover it, and then it like fails, and then they think, oh well, it's permaculture, is stupid and it fails, but you're really just not thinking about your context and like what technology and building style works in your area. Maybe in an arid area that would work. So it's good. You've obviously experimented with these things more extensively, so it's good to hear your opinion about that. I'm sorry to take more time on this, but traditional masonry stoves, what are your opinions about that? You know what I'm talking about, where it's like the stove is built into so much masonry and brick that sort of holds the heat and releases it?
Right. In Sweden or Russia, it'd probably be a good idea. I don't think so. What I think is really critical from the beginning of your design process is to take renewable energy seriously, understand that conservation and cooperative use come first. And then, as you go through that design process, invest in good technologies. Because what happens is people want the big square footage and the Tesla and the yard, whatever the bullshit. And then they shortchange the solar stuff, the renewable energy stuff. But if you get the design right, you get the cooperative use right, you do a really good job on conservation, then whichever technology, at that point, it'll kind of be obvious. So yeah, in the Arctic Circle, those big masonry stoves probably make sense. I don't think they make sense in Virginia because our solar is actually okay. I don't,
right.
Let's say you're going to build a house for X dollars, whatever that dollar is, amount of money is, you really want to make sure you invest in good renewable energy systems. In northern Sweden, yeah, probably like 3-foot thick walls made out of, I don't know what, straw or something. And yeah, some big masonry stove, maybe. I don't know. I'd have to figure it out.
Yeah.
But that's not what you're going to build in Puerto Rico or Miami. I mean, the earth ships, for instance, I think those are fine in the desert. I don't think I want them in Virginia. It really is like, what is your local climate? The pizza ovens, I am not on board with those things. They're not efficient. And what you're talking about with food, yeah, when I tell people about farming, because we're a farm too, I say, yeah, you can study permaculture, study all this stuff. That's great. But the way you learn to grow food is by growing food. You sit your butt down on a piece of land for 3 years and you will learn how to grow food on that land. Of course, after 30 years, you'll know a lot more.
Right.
But you cannot learn how to grow food from a book. You got to do it.
Yeah,
And we get the same lecture. People walk in here, yeah, why don't you do, swales, food forest, whatever. It's like, well, actually, we grow a lot of persimmons on trees, and that's our food forest. But people got the chip on the shoulder, or they make money off of teaching permaculture classes, whatever. And that is what it is. It's fine.
yeah.
I
I
wanted
know.
to.
I'll just make one comment and then I want to toss it back to Josh. But yeah, I think that probably a lot of the people who have a chip on their shoulder, they think that there is one thing I just want to repeat over and over again. There is no standard way to do things. It's going to be context and locally specific. And any sustainable society, this insight comes back to me over and over again, is context specific. Of course, it's ecology specific, it's geography, it's climate. So that's one thing we just have to keep hammering home, I think, on this podcast, which is different from mainstream environmentalism, which thinks, you can have one solution and you can export that everywhere in the whole world and it should scale, horizontally everywhere. I think if you're going to be really conservation minded, you're gonna have to just deal with the specifics of the place. So Josh, sorry I cut you off.
Yeah, that's a good segue. Context specific stuff, and particularly the human ecology. So you're out in the county now, and you mentioned a couple times previously you had a project in Charlottesville. I'm curious, have you run into any problems like with code inspection or any? I mean, you could design a great way to compost your poo, but then are they going to give you a permit for a septic tank? Have you run into bureaucracy? And especially if you're in town in Charlottesville and you're like, we want to do this because it makes sense actually, but is there a big barrier of regulations, or how have you navigated that?
I mean, I don't have a simple answer to that question. I mean, just to step back, I agree completely about the local solutions aspect, adapting to local context. And maybe it's the same answer for the legalisms. There's not an answer, not a specific answer. Yeah, there are a lot of legal barriers depending on where you are to, gray water systems, to even just cooperative living. Most cities have cohabitation laws. What's funny in Charlottesville is they just threw out their cohabitation law because the price of housing has gone through the roof. So they kind of caught up with us, which is cute, which will happen eventually in a lot of these things. I mean, what I tell people is if you can fly under the radar, great. If you can't, then you want to be, develop a positive relationship with your local bureaucrats. I think those are your two options. But yeah, it can be a big pain in the butt.
Actually, do you have
Zoning.
something else?
No, no, I don't. I mean, I could go on, and I think it would be really interesting at some point to dig in greater depth to see the systems. I guess one other question I have is I know you talk a lot about energy at Living Energy Farm, but do you want to just briefly describe how you all think about your food and farming system? I think a lot of people on our podcast are very interested in sort of diverse stacked systems, permaculture, food forests, tree crops, multi-paddock grazing systems, and this kind of thing. So I'd be curious to hear how your work with energy or your thinking about energy has influenced how you all pursue food and food self-sufficiency.
Sure. So yeah, my partner, wife, Debbie, she's the one who primarily has run the farm, and the farm is small scale. It's like 4 acres or so, plus orchards and whatnot. The biggest issue around food self-sufficiency is to eat what you grow and grow what you eat. So you may like avocados, but what we can grow easily are beans, corn, sweet potatoes. So we eat a lot more sweet potatoes than the average American does, and I love it. In fact, we have like a dozen or more different varieties, so we get to pick and choose the best sweet potatoes. The standard practice of organic farming, where you keep the land covered year round with something green, is important. We are certified organic, and mainstream organic, of course, is a complicated mixed bag, and we don't need to talk about that. The whole tillage issue gets ticklish. We have done some no-till, and we do some tillage. It's really challenging to do no-till and earn a living. So we're working with that. People walk up the driveway with all these ideologies. As a farmer, you just got to figure it out, year to year, and climate change has not made it easier. And we grow seeds. That's economically, that's the backbone of the farm. Southern Exposure has been our primary customer, but other companies as well. So we contract, we do a lot of vegetable seeds, some grains. So that has been what we can make money off of. And that's good because you can do it small scale. Beyond that, for tree crops, we do as much as we can there, and persimmons. In fact, check this out. I eat probably, I don't know, maybe 10% of my annual caloric intake is persimmons.
I love that.
This is dried persimmons. So we're just now, okay, this is going into late January. We're just now finishing up the fresh persimmons, and then we're going into the dried persimmons. These things are like gumdrops. And with a persimmon tree, they can grow, there are limits, but they grow in a lot of different climates, wet ground, mud, sand, gravel, they grow on anything. The American persimmons you can graft, the Asian and the Asian American cross. Our two favorite persimmons are the Rosianka and the Nikita's Gift. Those are both American Asian crosses. That's what this is. That's what we named our kids after. So for tree crops, those are the best. There's a few other Asian American crosses. There's one called Zima Kerma that's really good. We do jujubes. A lot of Americans are not familiar with those. It's another great tree crop. Blight resistant pears, depending on what climate, again, you're in. In a drier climate, you can do more varieties. But here we got to have stuff that really stands up to the blight. A lot of berries, they're super easy, but not a real food self-sufficiency thing. And for us, we're able to mix the food self-sufficiency with the seed growing. For instance, we can grow peppers, and then sell the seed from that, but we take the pepper itself. We have a little hand crank slicer that cuts it to ribbons really quickly. And then the heating system in the kitchen, it's a hot air system that pulls hot air off of a solar hot air collector on the roof, takes it down and blows it through the gravel. Well, we built a closet around the hot air blower, and that becomes an industrial scale food dryer.
Oh, wow, how cool. I love it.
Yeah, so we do a lot of dried food. I mentioned before, solar air conditioning is possible, but it's difficult. Solar refrigerators per cubic foot are kind of pricey. So we have a refrigerator, mostly because we know other people want refrigerators, and we do short-term storage. But our long-term storage is canning and drying. And then we do all of our own wheat. We do all of our own corn. The wheat is tied in with the harvester I mentioned. So we have, our own homegrown, home-cooked wheat year-round pretty much, which is great. We've learned to do cracked wheat where we run it through the grinder and grind it coarse, and that's great for any time. You can cook it like rice or cook it like breakfast cereal, whatever. So that's really the big thing is figuring out, what works where you are, and then figuring out how to eat what grows where you live. The animal thing is complicated.
You have animals as well in your farm system?
Right. That's another one of those big, complicated, ticklish issues. We do have some ducks. This farm was originally clear cut long before we got it. And we had a lot of ticks and bugs. And the ducks are really helpful. What is true in the general sense is that 8 billion people can't eat meat 3 meals a day. Just can't happen. Defies the laws of physics. And there's a lot of greenwash. Just like people want to drive their electric car, people want to eat a lot of meat and make it environmental. When you actually live on a farm, you have a relationship with whatever animals you have. So we have some ducks. We don't eat the ducks. We eat the eggs. They catch the bugs. They have a good life. That works out. We have a hound dog that helps chase the deer away, and that helps our crops. So we have a relationship with that animal. The idea that you can pasture enough animal to feed animals, whether they're sheep or goats or cattle or whatever, to feed a lot of people is straight up bullshit. It's greenwash. The cattle of the rich eat the bread of the poor. That's Gandhi. That's a big, big issue. Half the species on the planet have gone extinct in my lifetime, and that's because of cattle. That's not because of cars. It's not because of airplanes. It's because of cattle. And because rich people out of Europe developed beef in particular as a high status food, and then that spread all over the world, and it's devastating. So now that said, it's not for me to go to somebody anywhere else in the world who has a small farm and say, you have to live like I live. You have to figure it out. It's back to that local solution. So, that said, humans, just for human health, our digestive tract is longer than a cow. The American diet is terrible for a lot of reasons we don't need to discuss. But yeah, if you can make animals fit into your local thing, you figure that out. We're not feeding 8 billion people on beef and fried chicken, not happening. And the long run, I think, the relationship humans have with animals, if this world could somehow be more equitable, yeah, we'd figure that out. In some places, it would be different depending on where you are. And the thing with rich people eating themselves to death with meat just needs to go away. It's an environmental devastation. So I'm a little, there is a lot of greenwash caught up in the animal agriculture thing. People tell you that they're going to, turn a desert into a forest with cattle. It's like, it's crazy. It's stupid. It's wrong. Cattle are the single biggest environmental footprint we have, unquestioned. So, does that mean we should not have any animals? No, you got to figure it out.
Mm.
What about you mentioned that you have a dog to chase a deer away. Do you ever like just hunt the deer and get a source of meat that way? Or you're just like, well, we don't really need meat, we're fine without it, so we don't bother.
No, we do. I mean, we've had a $10,000 seed crop can fit in the area of my living room. I mean, it is a big living room. And our number one biggest problem as farmers in Virginia is the deer. We can pump water with our solar pump. It's great. We put up deer fences. If we have a late frost, we can replant, but those ding dang deer can devastate. We have $30,000 worth of seeds. That's a high end. We do $20,000-$30,000 worth of seeds. And there are years we lose a third of the crop. So yeah, we do shoot them occasionally. It's not, I don't like doing it. I don't eat them. Other people eat them. But yeah, like I said, it's a local thing. Of course, the game management tries to maximize the number of deer and then kill the coyotes. We have coyotes, coy wolves actually, what are around here. And they're my friends as far as I'm concerned. But yeah, we do kill deers and sometimes squirrels, groundhogs. It's not what I like doing, but if you're a farmer and you're trying to earn a living, you're trying to grow your food, you do what you got to do.
Yeah, yeah. Well, this is really, really cool. It's been great to hear your opinions and your experiences. I have to say I'm so impressed at all of the different experimentation you've done with energy systems. I think it's worth repeating just at the end of this podcast. One thing that really differentiates what we think and I guess talk about on here is from mainstream environmentalism is you just can't sort of plug in the system we have already going to just something called an alternative energy system and expect everything to work out. It's really a combination of overall reduction, living in the specific context of your own environment, ecology, and then experimenting with alternative systems. And in that last part, you really are way above. I mean, there's other people experimenting with this sort of thing, but I'm not sure at the level you all have with these different systems and thinking about at the level you are. So it's been really, really cool and really interesting to hear you speak. And anyone who's listening, who's either a researcher, where these academic researchers, if they pitch it correctly, can get access to huge amounts of grant funding to study these kinds of systems. Get in touch with Alexis if you're this kind of researcher who lives in this world of sort of like alternatives or sustainability. If you pitch it the right way, you can absolutely get giant grants to fund further research and to help Alexis and Living Energy Farm doing this stuff. Mostly I'm assuming self-funded or funded by these small enterprises. And then VC funders, if you're not going to be predatory, get in touch with Alexis. Anything else, Josh, before we finish?
Yeah, absolutely. So livingenergyfarm.org and livingenergylights.com are the two main sites to look at. I'm wondering, and I'm kind of asking for myself too, do you have programs for people who want to come and learn about specific components that you're working on? Do you offer apprenticeships or sort of day programs, or what opportunities are for people to do hands-on in-person learning at your site?
Yeah, we do tours. People can come out and look at it. We do a very limited number of interns. Like I said, a few more in the summer than in the winter. And there's a couple of bedrooms open in the house, but it really is personality based, or people we get along with, people who can really plug into the programs. So if you come, do a tour, we can talk. If you want to do something, we would just try to figure out how to plug you in. And we have in the past done what we call immersives, where we bring people out for 3 or 4 days and kind of like give them, a more in-depth set of workshops around how the systems work. And maybe we'll go back to doing that. The work in Puerto Rico has absorbed a lot of our attention, but yeah, we certainly want the ideas to get out there, but we also have to we're stretched, we're doing a lot, doing what we can. And there's, we don't do the ecotourism thing. If you're coming out here to use up my time so you can feel better about it, I have to figure that out, and we have to. So, but yeah, if you want to come to a tour, let us know. If you're sincere about helping this technology spread, let us know.
Awesome. Thanks so much.
Yep, certainly. Thank you for having me on.
All right, Alexis, thank you for your time today. This has been great, and we'll catch up with you maybe in a while and see how things are going.
Great, sounds good.